All right, let us discuss about piecewise-defined functions. Piecewise-defined functions are functions whose definition involve more than one rule are called piecewise-defined functions. In our previous discussion, for example, a quadratic function is represented by one function, one set of functions, but in case of piecewise-defined function, depending on the interval, we can have more than one. For example, if you look at this one, the first piece is 1 minus 2x if x less than negative 1. The second one is x minus 3 if x is greater than or equal to negative 1. So look at this one. These are intervals. These are important intervals. So this one is, look at it, is opens at x is equal to negative 1 and to the left side, of negative 1. When you look at this one, closed at x is equal to negative 1 and to the right of x is equal to negative 1. Now, when you plot the graph of this one, we need these pointers as a reference. Now, in order to graph, consider the first piece. Let's consider the first piece. The first piece, which is f of x is equal to 1 minus 2x. So in order to plot the graph, we can use x equal to negative 1 as a reference point for both. So let's find the value of y for the first piece when x is equal to negative 1. Then 1 minus 2 times negative 1. It is 1 plus 2. It is 3. Then order pair is negative 1, 3. Remember, this one is open. Right? Now the second thing, consider another point to the left of x is equal to negative 1, because the first piece is defined only for the left side of x is equal to negative 1. Let me take simple number. For example, let me take x is equal to negative 2, which is on the left side of x is equal to negative 1, and evaluate the function. So f of negative 2 is equal to 1 minus 2 times negative 2, which is positive 1 plus 4, which is 5. The order pair becomes negative 2, 5. This one is, it is defined and it is closed. All right, so I have to join the 2 pointers. Then consider the second piece, and the second piece, which is f of x is equal to x minus 3. Then evaluate at negative 1, so negative 1 minus 3, which is negative 4. So the order pair is when x is negative 1 and the y becomes negative 4. Remember that this point is closed, because look at the problem. Now take 1 point to the right of x is equal to negative 1. Let me take a number, for example, x is equal to 0. Then let me evaluate. So f is at 0 for the second piece is 0 minus 3, which is negative 3. So the order pair is 0, negative 3. Now I have to join these pointers, but I have to be careful when I join pointers. Remember, the first piece we have -1, +3, -2, 5, and so on and so forth. The second one, it is -1, -4, and 0 with 3. So this is the x, this is the y. For the first one, when it is -1, I got a result which is +3 somewhere here. +3. So this is -1, +3. If I put -2, I got some point here, -2, +5. So this point for the first one is open because it's not defined. Then I have to draw on the left side straight line. All right, for the second piece, when x is -1, it is -4, right? -1, let's say -1, somewhere here it is closed, -1, +4, and when it is 0, it's somehow 0, -3, and draw the line. So the graph looks like this one. Now you can see that this is the graph of f of x is equal to x minus 3. This one is the graph of f of x equal 1 minus 2x. Look at your graph. This is from the left side, right? This is, look at this piece on the right side. Let me use the red. Right, so from this one up to this. So these are known as piecewise defined.